In this video, I'm going to demonstrate sketching a slope field for a differential equation. A slope field is simply a series of short line segments that tell us what the direction of the slope is at any given point in the xy plane. So for a variety of combinations of x and y, we can get different slopes. Now, this differential equation is solved for dy over dx. So all we want to do in order to determine what the derivative would be like at these different points is to make a table of y and x and plug it into the differential equation. So first, I'll try the combination of 0, 0. Now, according to the formula, dy over dx is y minus x. Therefore, if I use the combination of x equals 0 and y equals 0, we get 0. So I want to put a 0 here. We can try dy over dx for 0, 1. That would be the space above the origin. We're going to get 1 minus 0, which is 1. So we want to put a 1 there. And we would continue to do this just like we had done for other multivariable functions. Until we can fill in the table. Okay, now that my table is complete, I want to go to the plot of the xy plane and start to fill in my slope field. To do it, all we have to do is create very short line segments that have the slope given in the table. The first one here in the origin has a slope of 0. So I want to start to draw a horizontal line segment. And that's all I need. Now, above it, there's a slope of 1. So now I want to go to that same location, 0, 1, and start to draw a segment that has a slope of 1. Above that, we have a slope of 2, so I want my line segment to be even steeper. Below, we have a -1 slope, so that would look like this. And then a -2 slope, which would be like this. And we want to do this for each point in the xy plane. There we go. The slope field is complete. The slope field plot is complete. Now there are online apps which can plot slope fields for us too. Desmos.com offers a nice slope field plotter. Now this is the function that it just comes with as an example. And so what we want to do is we want to change the 2x over y. Now, notice that they say g is defined as the derivative, dy over dx. We need to have our differential equations solved for dy over dx. Now, let's get rid of their function, and let's go back to what our problem had used. Our problem was dy over dx equals y minus x. So we want to type that in. Okay, and this is the result we get, which looks quite a bit like what I had drawn freehand. There's a movable point, which will show the slope at different points and see how it's changing as I move around the xy plane. Try plotting the slope field for this differential equation, dy over dx equals x minus 1. Then I'll draw it, and we'll confirm our results with Desmos.com. All right, so this time our formula is dy over dx as a function of x comma y is x minus 1. So it doesn't actually depend on y here. We just have to take the x values and subtract 1 from it. So we're going to get negative 1s all in here. We'll have negative 2s, negative 3s, zero, and 1. All right, we're going to want horizontal lines here. Slanted lines here. Negative slant. Okay, that's the slope field that I find by hand. Now let's use Desmos to confirm that. Change our formula to x minus 1. And yeah, it does look like what I had drawn by hand.